Hello everyone, my name is Adarsh Shukla and I am presenting a presentation as part of my fourth year BTech studies at Faculty of Engineering at Technology University of Lucknow. Today's presentation centers around my seminar topic, which is Beyond the Norm, Magnetized Water and its Influence on Concrete Strength. Thank you for joining me today. Let's take a quick look at the roadmap for our discussion, which is as following. Let's begin by understanding the significant impact of concrete production on water resources and the environment. In the realm of concrete production, an astonishing 1 billion tons of water are consumed annually. This staggering figure underlines the substantial role for this industry playing plays in global water usage. To put this into perspective, the agriculture sector accounts for approximately 70% of water consumption, which the industrial sector contributes around 20% to the annual global water withdrawal. This highlights the widespread impact and the necessity for a closer examination of water consumption practices. Moreover, it's essential to recognize the environmental implications associated with the cement industry, a major player in concrete production. This sector is a substantial contributor to carbon dioxide emissions, a potent greenhouse. Understanding these aspects is crucial as we delve deeper into the complexities of such substantial practices in concrete production. With this foundation laid, let's move forward to explore key aspects and potential solutions in our journey today. Magnetized water. Now let's shift our focus to a fascinating aspect that has gained attention in the quest for substantial water uses in concrete production: magnetized water. Magnetized water, as term suggests, is the water that has passed through a magnetic flux. This process imparts unique properties to the water, influencing its structure and characteristics. The properties of magnetized water are noteworthy. Structural alignment in one direction. Through the magnetic treatment processes, water molecules exhibit a distinct structural alignment in a particular direction. This structural adjustment holds significance in various applications. Increased viscosity and surface area. Magnetized water experiences changes in viscosity and surface area. These alterations can impact the interaction of water with other substances, potentially influencing the properties of materials it come into contact with. Let's visualize this transformation. In the figure 1, we see water molecules before magnetic treatment, displaying their typical arrangement. On the contrary, figure 2 illustrates the water molecules after undergoing magnetic treatment, showcasing the structural changes brought about by this process. Understanding the impact of magnetized water in the context of concrete production is a crucial aspect of our exploration into substantial practices. As we proceed, we delve deeper into the implications and potential benefits of incorporating magnetized water into the production process. Let's continue our journey of discovery. Case study 1: Concrete mixes. Let's delve into a concrete case study that explores the effects of magnetized water on concrete mixes, shedding light on its influence on various parameters. In this study, we examined mixes composed of ordinary Portland cement and coarse aggregate with a maximum nominal size of 20 mm and a dry density of 1600 kg per meter cube. Water cement ratio, which has modified for different mixes, characteristics strength targeted at 30 Newton per millimeter square. Now let's uncover the key findings. Consistent early strength. Surprisingly, the early strength of the concrete mixes remained relatively constant even when the cement content was reduced by up to 25%. This suggested that magnetized water may have positive influence on the early strength of concrete, potentially allowing for resource optimization without compromising performance. Slump variation. The study observed a rise in slump indicating increased workability likely attributed to the enhanced viscosity and surface area of water due to magnetization. This change in slump has implications for the ease of placement and shaping during the concrete construction process. These findings from case study 1 offer valuable insights into the potential benefits of incorporating magnetized water in concrete production. As we proceed, we will further explore the implications of these results and their significance in the pursuit of substantial practices. Case study 2: Strength development. Moving forward, let's examine another compelling case study, delving into the impact of magnetized water on the strength development of concrete. Here are the key findings from case study 2. Strength behavior comparison. The study indicates that magnetized water concrete exhibits a strength development pattern similar to that of normal water concrete. It displays high strength at early stages and a comparatively lower strength at later ages. Compressive strength enhancement. With the addition of magnetized water, the compressive strength of concrete showed a significant increase, approximately 55.7% at 28 days and around 51.8% at 1 year. This suggests that the use of magnetized water positively influences the early and long-term strength characteristics of concrete. Short-term strength improvement. The study observed a notable increase in short-term strength at 28 days and improvements of 12.62%, 21.5%, and 45% in split tensile strength, flexural strength, and impact strength, respectively, when magnetized water was used in concrete mixing. Long-term strength enhancement. In the long term, concrete exhibit increased strength in tension 12.7%, flexural 29.3%, and impact 42.2% when magnetized mortar was used as the mixing water. This underscores the sustained positive effect on various strength parameters. Mechanism of strength increase. The increase in concrete strength used when using magnetized water is attributed to the filling up of voids and pores in the concrete with additional hydration products. This mechanism contributes to improved density and overall strength properties. These findings highlight the potential of magnetized water in influencing not only short-term but also long-term strength characteristics of concrete. As we progress, we will explore the broader implications of these results in the context of substantial concrete production. Case study 3. Efficiency and advantages. Our journey into the impact of magnetized water on concrete would not be complete without delving into the efficiency and advantages observed in case study 3. Here are the key findings of case study 3. Compressive strength increase. Concrete prepared and cured with magnetized water exhibited a higher percentage of compressive strength compared to normal water concrete. This suggests that the use of magnetized water contributes to enhance strength properties in the concrete. Efficiency enhancement. The percentage efficiency of concrete samples cast and cured with magnetic water demonstrated a remarkable improvement, being 20% more efficient than conventional concrete. This efficiency gain highlights the positive influence of magnetized water and the overall performance of the concrete. Reduction in cement content. An essential advantage observed in the reduction in cement content by up to 11% compared to conventional concrete. This reduction not only contributes to the efficiency of the concrete but also aligns with the substantial practice of minimizing resource uses. High strength properties. The strength properties analysis indicates that magnetized water concrete consistently produces higher strength compared to normal water concrete. This is a pivotal factor in considering the long-term durability and performance of concrete structures. Cost effectiveness and environmental acceptance. Beyond strength considerations, using magnetized water in concrete preparation is found to be cost effective, environmentally accepted, and requires low maintenance for the associated devices. These aspects contribute to the feasibility and sustainability of implementing magnetized water in concrete production. As we wrap our exploration of case study 3, we will reflect on the broader implications of these findings and their significance in the realm of substantial concrete practices. Let's proceed with our analysis. Benefits of using magnetized water in concrete. Now let's consolidate our understanding by highlighting the key benefits of incorporating magnetized water in concrete production. Increased compressive strength. One of the primary advantages is the notable increase in compressive strength. The application of magnetized water contributes to enhanced strength properties in concrete, promoting durability and long life of structures. Enhanced workability. Magnetized water influences the viscosity and surface area of water, leading to the improved workability of the concrete. This enhanced workability can simplify the construction process, allowing for better shaping and placement of the material. Reduced concrete weight. The use of magnetized water and has the potential to reduce the weight of concrete structures. This reduction can be beneficial in various applications, including transport and construction, where lighter materials may offer logistical advantages. Reduced cement content. Another significant benefit is the reduction in the cement content by using magnetized water in the concrete mixing. There's an opportunity to decrease the reliance on cement, contributing to resource efficiency and aligning with substantial practices. These benefits collectively underscore the potential of magnetized water as a valuable tool in optimizing the performance, efficiency, and environmental impact of concrete production. As we conclude our discussion, let's reflect on the broader implication and the further landscape of sustainable concrete practices. Let's move forward. Drawbacks of magnetized water in concrete. While the benefits of using magnetized water in concrete are compelling, it's essential to acknowledge and explore the potential drawbacks and challenges associated with this approach. Lack of consistent evidence. One significant drawback is the current lack of consistent scientific evidence across various studies. While some research demonstrates positive effects, the overall body of evidence may lack uniformity, requiring further investigation and validation. Limited understanding of mechanisms. The mechanisms through which magnetized water influences concrete properties are not yet fully understood. The complexity of interactions between water, cement, and other components possesses challenges in establishing a comprehensive understanding of underlying processes. Questionable practical significance. Despite promising results in controlled environments, the practical significance of using magnetized water in real-world construction projects is still a subject of debate. The translation of laboratory findings into practical applications may encounter uncertainties. Inconsistent results in different environments. The performance of magnetized water in concrete can vary in different environmental conditions. The factors such as temperature, humidity, and regional variations may impact the consistency of results, raising concerns about the broader applicability of this approach. Cost considerations. Implementing magnetized water technology may entail additional costs, including the installation and maintenance of magnetic devices. The economic feasibility of this approach in comparison to traditional methods requires careful consideration. Potential corrosion concerns. There are concerns about potential corrosion issues, practically in the context of reinforced concrete structures. The long-term effect of magnetized water on metal reinforcements need further investigation to ensure structural integrity. By acknowledging these drawbacks, we aim to foster a holistic understanding of the current challenges associated with using magnetized water in concrete production. As research advances, addressing these concerns will be crucial in determining the viability and widespread adoption of this technology. Let's proceed with a reflection on the implication of these drawbacks and consideration for further research. Future scope. As we conclude our exploration of the current landscape, let's cast our eyes toward the future and the potential avenues for further research and development in the utilization of magnetized water in concrete production. Variation in magnetic field strength. Future investigations can delve into the significance of magnetic water on workability, strength, and durability properties of concrete by varying the magnetic field strength. Understanding the effects at different magnetic intensities could provide valuable insights for optimizing concrete performance. Large-scale production systems. Designing methods and systems for large-scale production of magnetized water is a crucial step towards practical implementation in in situ concrete works. Scaling up the production of magnetized water can open avenues for widespread application in the construction industry. Exploration of higher grades and types. Extending the present investigation to include concrete of higher grades and different types allows for a more comprehensive understanding of the versatility and applicability of magnetized water across various concrete formulations. Non-structure analysis of MWC. Delving into the nanostructure of magnetized water concrete and can provide insights into the microscopic changes induced by magnetization. Understanding the alterations at the molecular level contributes to a more profound comprehension of the mechanisms at play. Effect of treated magnetized water investigates Investigating the effects of treated magnetized water on concrete opens up possibilities for substantial water management. This exploration can contribute to environmental considerations by repurposing wastewater in concrete production. Durability assessment with magnetizing salt water. Examining the effects of treated magnetized salt water on the durability of concrete represents a novel avenue. This investigation can shed light on the compatibility of magnetized water with different water sources, expanding the scope of sustainable concrete practices. The future holds exciting prospects for advancing our understanding of magnetized water's role in concrete technology. These purposed directions aim to contribute to the evaluation of sustainable and innovative practices in the field. As we wrap up our discussion, I invite my questions on our reflections from conclusion. In drawing our presentation to a close, let's reflect on the key takeaways and the current state of understanding regarding to the utilization of magnetized water in concrete mixing. Effectiveness under debate. The effectiveness of magnetized water in the concrete mixing remains a subject of ongoing debate with the scientific community. Varied research outcomes contribute to a landscape where opinions differ on the extent of its impact. Mixed study findings. Studies on the subject present a mixed picture of some claims positive effects on the properties of concrete, citing improvements in strength, workability, and durability. On the other hand, other studies find no significant enhancement, leading to a diversity of perspectives within the research community. Lack of consistent scientific evidence. One of the primary challenges is the lack of consistent scientific evidences across studies. The absence of a standardized methodology and inconclusive results make it difficult to draw definitive conclusions about the concrete benefits or drawbacks of incorporating magnetized water into the mixing process. As the scientific community continues to explore this area, it is imperative to approach the use of magnetized water in concrete with a balanced perspective, considering the findings and recognizing the existing gaps in knowledge. References. Before we conclude, I would like to acknowledge the sources and references that have contributed to the insights presented in this discussion. The information shared in this presentation is drawn from a diverse range of scholarly articles, research papers, and publications within the field of concrete technology, magnetized water, and related disciplines. These all are the references. Thank you so much.